Okay, another round of problem solving. To get your, and you want, again, go in your binder, get that problem solving sheet out. To get your car repaired, you had to pay $76 for the part and $32 per hour for labor. If the bill was $124, how many hours did the repair take? Okay, so there's the hours, and looks like we got hours and money, so that's 2 units. So the setup goes like this. All right, so I've got money and hours. Okay, hours. Hours is X, and money is Y. Okay, so per. Dollars per hour. Dollars per hour, we know it right away. It's 32. So I'll go construct my line. Okay, so I know that my M is 32. Okay, how much money did you have prior to the 32? It looks like $76. Okay, so my equation is 76 plus 32x equals y. And $124 is your replacement value. And that is going to go in for y. Okay. All right, so time to solve for x. 76 plus 32x equals 124. So let's circle that. We're gonna move 76 out of here. 32x equals 48, and then divide by 32, and that's 1.5. That's okay. You can have 1.5 hours. Again, easiest problem there is. Okay, next one. The numbers are kind of all out of whack. Just follow in order. You paint 2 square yards of a community mural in 3 hours, and a friend paints 4 square yards in 5 hours. How long does it take the 2 of you to paint 11 square yards when you work together? Okay, so you're finding how many hours it's going to take. So there looks like 2 units again. So I've got square yards and hours. Okay. Let's assign you always assign the x to the time and then the y to the other one. So per SQYD, square yards per hour. Okay, problem is we don't know that, okay? He can do 2 and 3, and then a totally different person can do 4 and 5, so different rates. So I'm not in a position to know what that is yet. And you got to understand that when you're doing work, you can set up this line, but the line is pretty useless because without any hours of work, you're not going to get any yards painted. So that is a direct variation, okay? So with direct variation, we go down here and set up ratios, okay? And there's going to be 3 of them because you have you, how many people you have. You have your friend, and then equal to what you can do together because you're eventually going to team up. So you want to put your time unit on bottom. That's got to go on bottom or this does not work well at all. So square yards. Okay, so the first person can do 2 and 3. Our next person, he can do 4 and 5. And then when they work together, the 11 is the square yards, so that's 11 over x, okay? So equals 11 over x. And then add these 2 together, so 2 over 3 plus 4 over 5. Okay, and that's 1 and 7 over 15, okay? Well, that's not going to work very well, okay? to make that into something that makes sense, you need to go to do another set and put 11 over x. And you're going to put 15 to the bottom. I can guarantee you that. 15 is going to the bottom. And then what you do is you take your whole number, the 1 times 15, you times those two, which is 15. And then you add the top number. 1 times 15 is 15, plus 7 is 22. Okay. So now I'm able to put a nice... So if I get that mixed number crap, I need to take the whole number times the bottom plus the top. So 15 times 11 divided by 22, and that's 7.5. So 7.5 hours. Okay, number 3. A full pool is drained at a constant rate each minute. After 4 hours of draining, it has 1,300 gallons of water. After 10 hours, it has 1,000 gallons of water. How many hours would it take a full pool to drain to 0 gallons? So the hours, and again, this looks like 2 units, the hours and the gallons. So this is the setup. So hours, gallons, and X is hours and Y is gallons. And then per, we have our gallons on top and the hour on bottom. All right, so let's, do we know the gallons per hour though? No, it's 4 hours, it was 1,300, and then 10 hours it was down to 1,000, so I don't know that, okay? So I'm going to leave that empty. Make your line x comma y plus mx y. Okay, we don't have the m. So that means we need to ask ourselves, is there any way the gallons would have started at 0? Y wrote up here, no way the gallons were initially at 0. You know they're not initially at 0 because they're going down, so they had to start higher than 0, obviously, to go down. So it's not direct variation, so you're going to have to use the y minus y, x minus x over here, and the y equals m x plus b over here with the combo, okay? Because you got to find where that started. Okay, so y minus y, x minus x. Now y is gallons, so we have 1,300 and 1,000. Okay, so 1,300 and 1,000. Okay, and then we have 4 and 10. So 4, 10. Okay, so that's going to be 300 over negative 6, and that equals negative 50. Yeah, it's negative because they're going down. Okay. Again, you got to use these two formulas to find your initial amount. Okay, so I know that my m is negative 50. Now it's time to find where the initial amount was at. So the combo we're going to use has to be in the same sentence. So 4 hours, 1,300 gallons. Okay, let's get rid of these 3 letters here. The y, so 4 hours would be x, so that's x, and this is y. So 1,300 is the y, and the m go up there. You see that, that's negative 50, and then 4. Okay, so I have 1,300. Negative 50 times 4 is negative 200 plus b. Put a 1 in front, circle it, okay? So negative 200, we got to get that out of there, so add it. And that's 1,500 equals 1b. We don't need that 1 in there, okay? So 1,500. All right, so we can write our equation. So 1,500 plus negative 50x equals y. Okay, 0 gallons is the replacement value. So what letter would that go in for? 0 gallons, so that would go in for our Y. So that's where we put that in. So 1500 plus negative 50x equals 0. Okay, time to solve for that x. You got to undo the 1500. So negative 50x equals negative 1500, and then we're going to divide. And that is going to be 30. So 30 hours. Once again, when I give you the hint up there, there's no way that that y started at 0. Then you're going to need to use these formulas to find the unknown information. Okay, number 4. A car traveling 70 miles per hour travels 75 miles farther than a car that travels 60 miles per hour. Find the distance that each car traveled. The cars travel equal times. So you need to find the miles traveled by car 1 and car 2. Now, you know that car 1 traveled 75 further, so I'm going to put a little plus 75 there so we know how to get that second answer. Now, we don't care, we're not going with units here. We're going to do the distance, speed, time table. Okay, so car 1 and car 2. Okay, so we have our speed. And remember, the speed is distance divided by time, so d over t, okay? You're going to put your distance, and that's s multiplied by t. And then your time, that's your d divided by your s, okay? All right, now your speeds. Well, we got set speeds miles per hour. One car is 70, and the other car is 60. Get those out of there. Okay, distance, that's the miles. Okay, that's the miles, just the miles, not the miles per hour, that's the speed. The distance is the miles traveled. Well, the only thing you see about that is the 75 miles, but it says further. Well, that means one of them is represented with the expression x plus 75, and the other is x. So the faster car is going to have the x plus 75, and then x here. All right, now the time, we can cross that out. The time is just the hours. Well, I don't have any hours in here, okay? None, nowhere. So I have to use this distance over speed. So for this car, his distance is x plus 75, and his speed is 70. This car, his distance is x, and his speed 60, okay? So we want to know, and we know that they traveled for equal time. So I know these are equal, okay? So I know that x plus 75 over 70 is equal to x over 60. And again, you can't just cross multiply and divide because there's two x variables. You got to use your A, B, C, D cross products. That needs to be set up, the equation with double parentheses on each side. And we know that A times B will always equal C times D. So A is x plus 75 times 60. And C is x and D is 70. So you can put ones here. Okay, so we distribute here and here. So that's going to be 60x. And we need to take 75 times 60, and that's going to be 4,500. Then over here, you're going to have 70x. Okay, those x's are on opposite sides. Balance out the smaller one on a story problem. And we have 4,500 equal to 10x. Divide by 10, divide by 10, and that's 450. Now, we know how we're going to get our second answer. We're just going to add 75 onto it, and that's 525. Okay, distance, speed, time table. It's the way to go. Okay. You're buying apples and oranges at the store. You have $9.78 to spend. You need 4 pounds of apples and 3 pounds of oranges. The oranges cost 25 cents more than the apples. How much does a single pound of apples and a single pound of oranges cost? Cost of apples, cost of oranges, and it looks to me like we have 3 units. The pounds of apples, pounds of oranges, and the money itself. So that's 3 units. So make your chart. So, again, what you want to do is put together how many units, the cost for a unit, for a cost for a single, cost single, money single, and money total. And then our other 2 units are the apples and the oranges. Okay, what's total cost? Total cost is $9.78. Okay, remember up here, this row is for money. You see the sign. This is for not money, non-money. So find numbers that don't have money. Well, 4 pounds of apples. 3 pounds of oranges. I guess you can add them and say it's 7, but I really have no use for this box. And we never have a use for that box. Okay, and this is for the actual money. You see it. So find your money amount. 25 cents, but it says, and the oranges don't cost that. They cost 25 cents more. So I'm going to be putting X plus 0.25 and X to fill these in. Okay, the oranges are X plus 0.25, and the apples are X. So 4 times X. Question, do you see a plus sign there? You do. So you need to put a 1 and do your distributive rainbows. Okay? If the plus sign's there. So that's going to be 3X. And 3 times 0.25 is 0.75. And we have our equation. All right, now just by looking at that, I see the equation, and I don't need a second. The X's, they're the same letter. I don't have Y. So I can go ahead and make my adding pyramid because they're the same letter. So that's 7X plus 0.75 equals 9.78. Okay, so minus 0.75 minus 0.75. 7x going to equal 9.03, and then we'll divide by 7. So 9.03, $1.29. Okay, so here's the x right there. There's a singular x. That's your apples. And then we just add 25 cents more onto it. Okay, so plus 0.25. And that's $1.54. Okay, number 2, there are a total of 700 tickets sold at a football game. Student tickets cost $3 each, and adult tickets cost $5 each. If the school made $3,078, how many student tickets and how many adult tickets were purchased? Okay, so we find the student and the adult. And that looks like we have 3 units. I should have underlined that. Students, money, and adults. So that's 3 units. And we will be making our table. So together, how many units? Single. Total is money in this problem. Yeah, it is. Money's one of the units. It's about a money problem. So money, money. And then student and adults. Okay, so S and A. Okay, question for you. What's the total cost? You don't put 700. I said money total, not the total whatever. 3,078. Okay, now let's talk about how many. Remember, these are for numbers that do not have money amounts. Okay, this is for non-money entities. So that's a money, doesn't go here. That's a money, doesn't go here. Oh, that's not a money, 700. So it goes here, all right, but it's not students or adults, it's the together. Okay, so that's X and that's Y. You use X and Y for the two separates when you know the together. Okay, now with that being said, I have no use for that. Never do. Okay, so money amount, students, $3. Adults, $5. So X times 3 is 3X. Y times 5 is 5Y. Okay, so these are different letters. They can't be added, so I'm going to need my system to solve this. So I have this equation here, but these can't be added. I needed a second equation, and that's going to come from my top row. So 1X plus 1Y can equal 700. 3X plus 5Y equals 3078. All right, your x's, no common absolute value there or there, so you need to do your dot, dot, dot. So I have 3, so 3, 3, 3, and then 1, 1, 1, 1. So 1x times 3 is 3x. 1y times 3 is 3y. 700 times 3 is 2100. Okay, and then the bottom, 3x plus 5y equals 3078. Okay, here's your match, but they got to be the opposite. They can't both be positives. So you need to go negative, 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 and then add, and those add to 0. That adds to negative 2y, and 2100 plus negative 3078 is negative 978. So divide by negative 2. Okay, so negative 978 divided by, is 489, okay? And that's your y. So there's my y under adults, so 489. Okay, and you can either use a little common sense across that top row, or you can plug it into one of the originals, probably the 1x and 1y. So 489. We're going to times that, so 1x plus 489 equals 700. We're going to minus 489. And 1x equals 211, okay? Okay, last problem. I crossed out the back page, okay? 2 schools buy helmets and uniforms from a store. The school buys 5 helmets and 7 uniforms for $250. The other school buys 7 helmets and 10 uniforms for $354. Find the cost of a single helmet and cost of a single uniform. So there's my answers and another 3 units. Okay. Okay, so we got together. And we have how many? How many units? Single. Total, and money's in here, so money single, money total. And then the things we're buying are the helmets and the uniforms. Okay, so find your money total. Well, there's 2 different totals. You have 250 and you have 354. So, oh yeah, it's one of those kinds. So 250 and 354. Okay, now up in this right here, we're on the lookout for numbers that have nothing to do with money. So 5 helmets. Again, when you get these 2 totals, you don't want to draw your numbers huge because there's probably 2 of them. 7 uniforms. 7 helmets. and 10 uniforms. So out, 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 and then that's it. So I don't need to have any use for this box. I never have a use for that box. And I have no other numbers, okay? We're out. So that's X and that's Y. So 5 times X is 5X. 7 and somebody's going to ask, how do you know that that's X and Y? You only use X twice. You only use X, like double X's, if it's a more than or a twice. And that wasn't happening here. So that's 7X. More than and twice expressions are just, both of them would be represented with using X, but not anything else. You need X and Y. So 7Y and 10Y. Okay, pretty easy to see where the equations are at, but they have X and Y. So I have 5X plus 7Y equals 250. 7X plus 10Y equals 354. And I have no common absolute value there or there, so you're going to have to do the times, times, times. Okay, so I have a 5 in the lead there, so take that to the bottom. I have a 7 here, take that to the top. So 5X times 7 is 35X. 7 times 7 is 49Y. And 250 times 7 is 1750. Okay, and then you're going to get another 35X just on cue, and then 50Y, 10 times 5. And then 354 times 5 is going to be 1770. Okay, now I have my match right there, but they can't both be positive because they're not. You always want to add, and 35 plus 35 is not 0. But it will be if you go negative, negative, negative. You got to do it to all three terms. So add those, you get negative 1y. Add those, you get negative 20. Okay, and then you divide by negative 1. And y equals 20. Okay. So here's my y. That's your uniforms. They cost $20 each. And now pick your original top equation. So 5x plus 7y equals 250. So I know y is 20. Okay, so I know we have 5x, and then we take 7 times 20, and that's 140. Remember, equals 250. Then minus 140, minus 140. And 5x is 110. Okay, divide by 5, and that's 22. Okay.